Good morning. This lesson is for my Integrated 1 classes. Before I continue, I'd like to say that I hope everybody is doing okay out there. So we only have one goal today, is solving for values other than x. What's nice about this lesson is we already know the steps that we can use, steps 1 through 6, and we're just going to apply what we know to a slightly different variation or twist on a problem we know how to solve. So if you solve a problem like this, you probably, realize that it can be solved by subtracting 5 to both sides, and then you get your value for x. But remember, this lesson is about solving for values other than x. So in this lesson, I am asking you to solve for 5. And we actually did this problem at the beginning of the school year, and I used this problem to show you that we would be able to move variables to the other side of the equation. But again, I'd like to just review this with you. So let's go ahead and go through the steps that was allowed. 1, 2, 3, 4, 5, and 6. Can I eliminate a fraction? No. Can I distribute? No. Can I combine like terms? There's no to combine. Are all my 5s on one side? Yes. Can I add or subtract a number away from the 5? And the answer is yes. I can add or subtract away the x. So I'm going to be left with 5. And that's equal to 7 minus x is a value that I don't know. So I'm going to leave it as 7 minus x. In mathematics, you are allowed to leave numbers in forms that you don't know. That's fine. So the actual answer is 5 equals 7 minus x. And we can actually check this. We can plug in this value into 5 and see if we get a true statement. So instead of writing my equation with a 5, I'm going to write it with an empty parenthesis. Remember, I solved for 5, and I'm going to see if I get a true statement. So let's see here, 7 minus x. So I can remove the parentheses, x plus 7 minus x equals 7. I can actually combine like terms, my minus x's cancel, and 7 equals 7. That's a true statement. So that means that I do in fact have a solution, and the solution for 5 is 7 minus x. Or you could have also said minus x plus 7. That's also a solution, minus x plus 7. That would be another way to write that. So that's one example of this. Let's move on to the second example. Again, I'm going to write my steps 1, 2, 3, 4, 5, and 6. And remember, I can only ask you about these 6 steps. And before I move on any further, I want to point out that all the steps can repeat in this. Okay, they all can repeat. So here I'm asking you to solve for m. I want to get m by itself. And so let's see, can I get rid of a fraction? No. Can I distribute? No. Can I combine like terms? No. Are all my m's on one side? Yes, so I can't do step 4. Can I add or subtract away a number from the m side of the equation? And in fact, I can. I can subtract b to both sides. My b's cancel. I don't know what y minus b equals, so I'm going to leave it like that. So y minus b equals mx. So I did step 5. All right, my last step is divide away a number. It says divide away a number from the variable side of the equation. But remember, I want to get m by itself. And who's keeping m from being by itself? It's x. So just like before, we can multiply everybody by a number. We can also divide everybody by a number. So what I'm going to do here is I'm going to divide everybody by x. Everybody gets divided by x. So I'm doing step 6, and that means that my final answer is y over x minus b over x. That is equal to, those cancel, that's equal to m. So I solved my equation for m. So again, with this lesson, I just wanted to show you, it's not really a lesson, it's just us using our steps in a quirkier way on problems that look like they're more difficult, but they're actually, really they're not. So hopefully this helps us to understand how to solve for values other than x. We're still using our steps, we're just being a little bit creative with them. Hopefully this helps, and have a good day, everyone. Bye-bye.